a gallbladder, that is what we call a cholecystectomy, very simple operation. In United States, you have per year, 5,000 severe complications. Severe complications. That means some of these patients, they lead to the hepatic transplantation. So even if it is only 5,000, it's a big economical problem. So the next generation of robotics, not this one, but the next generation, integrating artificial intelligence, you will have so many alarms. So that means if the computer see that the surgeon follow a strategy that he has never seen before, because he will have integrated inside thousands of operations, immediately you will have an alarm. So it's exactly the system today of aeronautics, for example. So I'm really convinced that the next 20 years will be a total change in the safety of surgery due to the development of your science.
Perfect. Absolutely fantastic. Thank you so much. You've definitely started the day off with a bang, so we can't appreciate you enough. Professor Jacques from IRCAD France, IRCAD France, he's the president there, and he's been giving us what is supposed to be the future of surgery and a new hope for Africa within that same domain. Prof, I can't appreciate you enough. I told you yesterday that studio was absolutely phenomenal, and you've definitely shown us how to use it properly. Thank you. Yes, I see. I see. So please, for the interest of time, just allow me to ask everyone to jump to the sessions. This first session is done, so please just go to sessions, and then we'll carry on with the rest of the program. Prof, thank you very much.
Thank you very much. It was a pleasure.
Fantastic. Please, everyone, let's just go to sessions. Then we'll go to one particular session where we will highlight the NEF video, the next Einstein Forum Spotlight Session 2, and then we'll carry on with the plenary discussion. So we won't have any time in between because we're running a bit behind on time. So please go to the sessions. We'll have the NEF Spotlight session right now.
Human urine is considered gross, right? What if I told you that this waste has the potential to change the world if we think differently about it and if we innovate? The modern toilet is based on the assumption that we can waste water. We use between 30 to 40% of our daily water usage just to flush our toilets. Consider this. Phones have changed significantly over the past century or so. And even rural communities will have a cell phone. But our toilets haven't changed since Victorian times. So why have we not innovated the toilet further? Prof. Jumit describes it best. People resist innovation because they fear a loss of some kind. From resistance to coffee, to digital music, people resist change, but they can get over this if the benefits are great enough. We have to innovate in order to provide a product, in this case, a sanitation solution, with greater benefits than our existing toilets. I think our urine is key to innovating the toilet. You see, our urine only makes up 1% of the total wastewater coming from our homes, yet it contains over 80% of the nitrogen, 70% of the potassium, and 50% of the phosphorus. Now, these are 3 key nutrients needed to make any inorganic fertilizer, and we literally flush them away every day. So how can we use urine to innovate in the sanitation sector? We first need to understand the chemistry, and as a chemical engineer, that's exactly what I do. You see, we need to understand it to prevent the loss of nitrogen as ammonia gas. That is the typical smell you have when you let urine stand. We discovered that increasing the pH of fresh urine above 11 prevents this loss of nitrogen, something that had never been done before. We tried many combinations of chemicals and operating conditions to determine the ideal conditions and failed many times, but we kept on going, trying to understand the fundamentals of what was actually happening in terms of the chemistry of the urine. Along the journey, we even found that the urine treatment process we discovered gave the urine a sweet-smelling odor, and later discovered that this was even attractive to female mosquitoes. Once we understood the chemistry, we needed a way to collect the urine, but a system that used no water, mainly because we were in a period of a severe drought in Cape Town. And this is how the fertilizer producing urinal was born. It's so easy to operate. We increase the pH by adding a special chemical called calcium hydroxide. And we pre-dose the urinal with this powder and then simply add urine. So if I pee in the container, a small amount of the powder will dissolve. And if you pee in the container, a little more dissolves. Provided you have enough powder in the container, you maintain a high pH and you prevent the loss of any nitrogen. We also found that this new process kills pathogens, prevents bad smells, helps degrade pharmaceuticals, and uses no drinking water to operate. It's really crazy how simple it is. Perhaps though the craziest thing that we did was grow a biobrick from urine. It took us many months and failed experiments, but in 2018 we grew the world's first biobrick. And when it went viral, a funny thing happened. Before, it would take 4 to 6 days to fill a 25-liter urinal container. Now, it takes typically 6 to 8 hours to fill the same container. You see, people wanted to visit the new urinal and donate the urine because it became fun and people wanted to be involved in this work. We are now working on upgrading the urinal, growing stronger biobricks, and even recovering water and a liquid fertilizer using reverse osmosis. So the next time you take a pee, I want you to think about the liquid gold you are about to flush away, and imagine instead a future where your urine is recycled, turned into fertilizer, water, and many other useful products. Think about how you can change the world one pee at a time.
Hi. My name is Jesse Gitaka from Mount Kenya University. Growing up in Western Kenya, malaria was the commonest illness that I suffered. And in fact, malaria almost killed me. After seeing this image of the potential for genetics to revolutionize medicine, I was fascinated and decided to pursue medicine to at least have a serious talk with malaria. Today, I lead a lab where we are working on the A to Z of malaria. Current tools to tackle malaria, such as bed net use and treating cases, have done a great deal, but it is clear that more is needed. One of the toughest challenges to stopping transmission is finding parasites that are hiding. Remember, they have evolved to exist without killing many of their human hosts or even making them sick, but will be dangerous to people with weaker immune systems, such as pregnant women and children. When mosquitoes bite these infected but not sickly people, they can transmit to other people. But how do you find out these asymptomatic infections? As we have learned from the current coronavirus pandemic, prompt detection is critical to timely treatment and control. And with malaria, self or imposed quarantine cannot work, since mosquitoes will find you even in your house. In my lab at Mount Kenya University, we are developing highly sensitive point-of-care diagnostics that use genetics of the malaria parasites. Remember my fascination with the Human Genome Project? It happens that we got stuck with malaria genome in the mix. Yes, malaria parasite genomes have repeating DNA segments that we can leverage for greater sensitivity, and we can do the detection on paper. We are also using the fourth industrial revolution genetic engineering tools, such as CRISPR, to design these diagnostics. Current tools are not sensitive enough. They are missing far too many infected yet transmitting people. We are working with teams in Africa and other continents to be able to detect the smallest amounts of infections well in time to intervene. This way, we will detect malaria in pregnancy and avoid or prevent the low birth weight babies, stillbirths, anemia, and even deaths of mothers that negatively impact our societies. we shall be able to cut the transmission cycle that persists throughout the year in endemic countries, enabling socioeconomic development and saving lives. Now, I have told you the A and B of what we do. The rest of the alphabet includes finding out drug-resistant markers in different parts of Kenya and the region, finding which parasites pose the greatest threats, finding out vaccine targets for malaria in pregnancy, and finding the best strategies for eliminating malaria. My lab is aimed at tackling a challenge that has dogged Africans for thousands of years, that is currently reducing the economic growth of African countries and impeding the huge potential of its people, that is costing lives and quality of lives. Please, join us in tackling this menace. Thank you.
What does Africa have to do to become energy independent? Constant power outages and lack of electricity are some of the stereotypes that Africa is known for when it comes to energy. The energy debate has been here for a while now. However, for Africa, our voice in this debate has been more like a murmur, if not a whisper. So how do we change the narrative? Suppose the energy problem is split into two: energy generation and energy storage. When it comes to energy generation, we've got this covered here on the continent, since Africa is well endowed with lots of energy generating potential, ranging from solar to natural gas. All that is left is how to harness and store the energy from these sources. When it comes to energy storage, the battery still remains the energy storage medium of choice. However, to date, there is no battery that can either last long enough or store enough energy to power Africa's villages towards energy independence. We must therefore invent alternative forms of energy storage, such as storing hydrogen in liquid organic hydrogen carrier systems. Liquid organic hydrogen carrier systems are not only environmentally safe, but also allow us to store energy for longer without energy losses. And the stored hydrogen can then be used further to generate electricity or even as a fuel. It is this concept that was going to be explored in the coming Tokyo Olympics game, where hydrogen was going to be used both as a source of electricity and as a fuel. Africa has many cutting-edge researchers with the capacity to design new materials for storing energy, such as liquid organic hydrogen carrier systems. However, to get to these next-generation materials in time to meet Africa's energy demand, computational modeling is the most promising way to augment existing experimental approaches to material science and design. By harnessing the capabilities of quantum mechanical calculations and high-performance computing resources that we have here on the African continent, we can, for instance, dramatically shorten the product-to-market life cycle of these energy storage materials. This therefore makes computational materials modeling no longer a luxury, but a necessity. So how is this done? To accomplish this, we use fundamentals of basic sciences, mainly physics and chemistry, to construct computational models of these materials, and then use quantum mechanical calculations, which is mathematics, to understand the behavior of the atom. This is because the atom is the smallest unit of matter, and hence the basic building block of any material. Thus, having a fundamental understanding of the behavior of the smallest unit of matter allows us to accurately predict the next generation materials. However, these quantum mechanical calculations are computationally expensive, hence require the use of high-performance computing facilities or supercomputers. Fortunately, the Center for High-Performance Computing in Cape Town, South Africa is available for free for all African researchers and academics. All that is needed is internet access and a login device. So, if Africa is to be on the path towards energy independence, there is a serious need for many more computational material scientists that can keep up with our homegrown experimental researchers within the continent. This is because we still do not have enough students pursuing careers in basic sciences, mainly mathematics, chemistry, and physics. Basic sciences understandably lose out to other nobler professions such as doctors, teachers, and even engineers when it comes to safer careers of choice amongst young people. However, the fourth industrial revolution is here, and with it comes the need for those like me who still desire to solve real African problems using basic sciences. The stigma associated with mathematics, chemistry, and physics here in Africa is real. When one declares interest in pursuing these subjects, you must contend with questions like, where do you intend to work? Or which future will you have with pursuing a career in basic sciences? It is my hope from this talk that you now have a clearer answer to some of these questions, which is, you can do everything.
My name is Agnes Chiraga. I work with the Infectious Diseases Institute under Makerere University in Kampala, Uganda. I am under the research department and I head the statistics unit. My career for the past 15 years or so is around data use and other technologies to address public health concerns and infectious diseases, including HIV, and trying to understand how data can be used in Uganda and globally. I am also a founder of the African Women in Science Hub. This is a newly founded non-governmental organization towards empowering young girls to take on sciences, STEM-based sciences, technology, engineering, and math. And my passion is to see very many African girls take on math, and also to find a way in which women in science can be empowered to advance their careers. So my interest in data has led me towards analyzing the situation of COVID-19 in the country. As we know, COVID-19 has devastated major parts of the world with about 65 million cases globally, and 1.5 persons have succumbed to COVID-19. Uganda is not any different. We have about 21,000 cases diagnosed so far, and slightly over 200 persons have died. And because of the government's endeavors to reduce COVID-19, there were many measures put in place to curb the epidemic. What we didn't know is how the public responded to these measures. How did they feel about them? What were their sentiments towards some of these measures? So this led me to analyzing a readily available data source, which is part of the social media platform, and this is Twitter. Uganda has seen an increase in Twitter over the past months during the epidemic, and due to this we thought it was important to see what Ugandans feel. Twitter is a good platform because it enhances persons to express their feelings in an explicit manner that can be then mined using data science methods to understand important aspects like, when do Ugandans tweet? Who are the top influencers in Uganda with regards to COVID? What are the sentiments of Ugandans towards COVID-19? And what are the ongoing myths in the country? So what we found was about, between March and October, there were over 150,000 tweets that we generated, and from about close to 100,000 accounts. This was important because we then were able to look at the trending topics around COVID-19, when people were tweeting, and we saw that during the lockdown, when persons were at home and it was a very tense time, there was a lot of tweeting going on and persons expressing their attitudes towards the measures and COVID-19 in general. When the country lifted the measures around July, we saw a huge reduction, about 50% reduction in tweets. This is the very time when the country was experiencing and is still experiencing high level of community transmission. So what we thought then was, what are the sentiments around COVID-19? We analyzed the sentiment analysis of all the tweets that we generated, and we saw that at the time the country was locked down, there were a lot of negative feelings. And as the country moved to opening several mitigation measures like public transport being opened, arcades and shopping malls being lifted up, the sentiments became more positive. So clearly, through tweets, you can tell the attitudes of persons towards COVID-19 measures. We then also looked at the influencers that were pertinent to the COVID-19 epidemic. We saw that media houses do influence so many persons in the country. A top TV in Uganda is NBS TV, that then had the greatest streaks and was a great influencer of COVID-19. And of course, the president of the country, Yoweri Kaguta Museveni, who has continuously increased his tweets with several followers. We then looked at the myths that are going around the country. We looked at the myths in relation to the WHO myths that are around COVID-19, and we saw that Ugandans thought garlic is a very good treatment for COVID-19 at the expense of putting on masks. We saw some hints of hydroxychloroquine, and we also saw myths around 5G being related to COVID-19. So there is need to enhance and educate the public about what should and should be done and believed around COVID-19. So my take home from all this analysis is, how can social media be harnessed to address public health concerns in the country? It's a good platform. Africa is on the increase in regards to using social media platforms, and they can be leveraged to address epidemics, to address very huge problems, particularly climate change or antibiotic resistance. And my next step out here is to call upon collaborators. If we can partake and use this data to address public health concerns in Africa, I think we'll be on the right path to solving several issues on the continent. Thank you.
Labs. I'll say a bit more about each one of them now. Eliane Ubalijoro. I've actually practiced it, but I knew I was going to get something not so right. Eliane sits in Canada, as you know, and Annabelle Schiff, who sits also in a distant, colder climate. She's with Caribou Digital. And I'm going to ask each one of them to just say a little bit about their experience of digitalization during the pandemic and their take on this question of, is it taking our society? Are we seeing some gaps? What's happening with infrastructure? Are we finding major gaps? Are we able to rapidly deploy? So let's kick off with Ben. Ben is sitting in the UK. He's Liquid Telecom's Group Chief Technology and Innovation Officer. He's been working in this field a lot. He's been working with networking and product strategy. Liquid is a major provider of fiber infrastructure and